Remember the last time you were under the weather? You can thank the chemist who helped you get better. Chemists synthesize medicine through a multi-step process, but one of the key steps involves reactions like SN2. This swap reaction helps create the compounds of modern-day medicine. So next time you pop a pill, remember the chemistry behind the swap. To get started, we need to learn the difference between a nucleophile, an electrophile, and a leaving group. A nucleophile is an atom that loves the nucleus, which is the positively charged portion of the atom. Nucleophiles tend to attack atoms with a formal or partial positive charge. It's helpful to draw a dipole moment to visualize the positive region. In this case, a partial positive charge exists on the carbon atom where a nucleophile would want to attack. The opposite of a nucleophile is an electrophile. An electrophile is a lover of electrons, which are negatively charged. A dipole moment can be drawn to find an electrophilic region. The partially positive region is the electrophilic site. A nucleophile, such as chlorine, tends to attack electrophilic regions. A leaving group generates the dipole moment on the substrate in the SN2 reaction, so it must be electronegative to create a partial positive charge on the carbon to which it is attached. A leaving group is an atom that eventually leaves in an SN2 reaction, but in order to leave, the atom must stabilize electrons, so it should be a weak base. Bromide, chloride, and iodide are examples of great leaving groups. Now, you're ready to learn about SN2. SN2 stands for substitution nucleophilic bimolecular. Let's take a look at the mechanism so we can understand what all of this means. The chlorine is our leaving group, the bromide ion is the nucleophile, and the electrophile is the carbon the chlorine is attached to. The bromide has a large electron cloud, as does the chlorine. So when bromide tries to attack the carbon atom, it cannot do it from the front of the molecule, it just bounces off. It must attack from behind the chlorine, which will cause an inversion of configuration. The leaving group is ejected from the molecule, and now we have our product. This reaction happens in one step, so only one transition state exists. The transition state depends on the amount of the reactant and the nucleophile. This explains why the reaction rate is bimolecular, which is what that 2 stands for in SN2. Let's look at one more example. Try to identify the nucleophile, electrophile, and the leaving group. Feel free to pause the video. All right, ready? The nucleophile in this case is hydrosulfide. The leaving group is the iodide, and the electrophile is the carbon attached to the iodine. The positive charge loving hydrosulfide will attack the electrophilic region from the back side of the iodine, causing an inversion of configuration. The iodine will then be the leaving group to give the final product. If you want more practice, check out the description for resources and a summary sheet. Thank you so much for learning with me, and keep testing the boundaries of science.